know, just in general, you should kind of know about what symmetry is. Symmetry makes things usually look kind of nice, right? Symmetry, if you were able to kind of cut you down the middle and fold you left to right, you should be kind of symmetrical, right? You should left side, right side, you kind of should match up nicely. Now, in shapes, certain shapes have symmetry. Not all shapes have symmetry. It depends on the type of shape that we have there. But certain shapes have symmetry. You see symmetry happening in logos of things as well. So as we go through here today, we're going to take a look at reflectional and rotational symmetry and see if a particular shape has reflectional symmetry. Is there more than one line of reflection happening in that symmetry? And then we'll look at the rotational. Does it have rotational symmetry? And the way that we define rotational symmetry, I should back that up. The way that we define rotational symmetry, does it have rotational symmetry? Because there is just a small key on how we define rotational symmetry. Okay? So let's jump into it today. It's not a bad lesson for a Friday here. Happy Friday to you. Let's go right at it. One more time, 146, I believe we're on there. And reflectional symmetry is basically like what we've been talking about here. Okay, can we draw a line so that a figure can flip onto itself? And we've done a little bit of work with that throughout the last couple weeks. So let's again jump right into it. Let's go to this. Now, as we look at that shape, that's not just any old triangle. What type of triangle is that? That is a equilateral. One more time, let's do a little bit of vocabulary. What does it mean to be equilateral, guys? Equilateral triangle is? Correct. All sides are the same. That definitely makes a difference there, because if it's not equilateral, it doesn't necessarily have something's happening with it, okay? So, do we have reflectional symmetry here? Yeah. Something going on out there? Oh, it's the class out. Gotcha. Okay, I'm sorry. So do we have reflectional symmetry happening here? Yes, we do. Now the follow-up is go draw those lines in. Where is my line of reflectional symmetry happening here, guys? Right, I think I heard down the middle, right? Right down the middle, right? So let's go ahead and draw that reflectional symmetry happening right down the middle. Is that all we got? Is that the only line of reflection happening there? No, where else do we have it? The other kind of vertex, right? Going through the other vertex here. So now kind of mentally erase that line of reflection, and then couldn't we also do, not stellar on my end, this is where probably your ID would be helpful, kind of make a nice crisp line. Do we have another line of reflection? Yeah. Through the other vertex, right? With this being an equilateral triangle, we have 3 lines of reflection happening, don't we? 3 reflectional lines of symmetry happening. So if we were able to fold that triangle on those 3 lines, right, that shape is landing on itself, correct? So that is having what? 3 lines of reflection. Nothing crazy yet. What do we got? We got a rectangle, don't we? Do we have any lines of reflection happening off that one? Okay, if we do, go draw them in, please. Take a second. Go draw them in. Let you draw them in. Now, the thing about this one is if you're having a hard time to see it, I said patty paper is not needed today, but patty paper could be used, right? We could do that. We did that with that the other day with the lines of reflection. See where it is that line of reflection happening when one shape falls into the other and finding that. You just quizzed up on that the other day. I put those into Skyward. I'll pass back those quizzes probably on Tuesday when we have a little bit of time. All right. But we could use our patty paper here. So take a second on that rectangle and turn to a buddy. Check your lines of reflection with the buddy real quick. All right. Turn left to right, up or down. Probably not. Are your lines of reflection correct? The one about the rectangle here is students sometimes think that these are happening. Are the diagonals happening? I had some heads go yes, I had some heads go no. Okay, get out patty paper then. Get out your patty paper. You don't have patty paper, get it out. So trace on that rectangle, please. Trace on that rectangle. And as you trace on that rectangle on that patty paper, trace on that rectangle. And can you fold one corner onto its opposite corner? Would that make, I think that would be it, kind of, right? Could that fold onto that? And that would be like a diagonal, right? Let's see, patty paper. Okay. So as we're trying to do that, one more time, I'm pretty sure everybody agrees, at least I'm hoping we're agreeing. There is a vertical line of reflection right down the middle vertically, right? Okay, a little bit better than what I have, right down the middle, right? And there's a horizontal. We all agree there. One more time. Is there the diagonals happening? You're using a patty paper. So the couple of heads I saw going up and down, I think are seeing some no's. So if you try to fold it along the diagonal, when you brought this, say this corner, and tried to connect it here, it wasn't happening, was it? This corner is landing more where? Like kind of here-ish maybe? All right. So what that tells me is that that line of reflection is not there, is it? So on a rectangle, what's the best we got? 2 lines of reflection. So if you're not sure if a line of reflection is happening, use that patty paper again.
Someone's at the door.
Do I care about it?
Probably not. Perhaps.
Okay, perhaps. Probably not. I don't know. I don't know.
No.
This hard class. Rectangle doesn't do it. What shape is close to a rectangle that might get me that diagonal's working? There you go. Okay. So there we go. Give me that square then. So in that square, we got the vertical and horizontal. I think we're all in agreement there, right? Still happening there. That's kind of the 2 captain obvious ones. But can we again say about the diagonals then? And again, if you're not sure, the patty paper is your buddy. Okay, you can definitely use that patty paper for us. On that patty paper, trace on that square, see if you can fold it along that possible diagonal, and that is happening, isn't it? So what do we have? Diagonal and the other diagonal. Is there anything else happening on that square? I don't think so. Okay. So how many lines of reflection we got on that one? 4. We got 4. Yes, there was 4, and this one only had 2. This one had what? 3. Okay. So lines of reflection happening off of that. Okay. Let's continue on here. We'll talk more about lines of reflection in just a few minutes. The other symmetry we're going to look at is rotational. Now, to be rotational, all right, let's look at the definition of it. Has to be more than 0. Well, duh. 0 doesn't turn it at all, does it? Okay, it's got to be more than 0. Less than 360. So what does that less than 360 mean? Can it be exactly 360 then? No. So it can't be exactly 360 because exactly 360 takes me back to where it started, right? So what that really means is, and what you're going to find out, it's going to be no more than 180. Okay, no more than or equal to 180. 180 is the max, is where we're going to be at technically, as we do a few of these, you're going to find out it's going to be somewhere between 0 and 180, inclusive of 180. Okay, so let's look at that first picture then. All right, on that first picture, do we have rotational? Now, we do have rotational, and then the follow-up's going to be, what is the degree of rotation? And when we ask you what the degree of rotation is, we always want the smallest turn possible. Okay? So what would be the smallest turn possible that's going to give you that rotation? 90 degrees. Okay? So as we look at this one, and patty paper is also helpful for us if we need to, but here, this turn of the paper would require just say 90 degrees. And usually we turn which direction? counterclockwise, okay? So counterclockwise, the smallest degree is 90, right? Now 180 would definitely do it as well, but when we say what's the degree of rotation here, we always want to find what's the smallest degree, and then any multiple that works. So as Carter said, 90, this has a 90-degree rotation then, okay? It has rotational symmetry is what we then say, okay? Let's go back up above. How about that? Let's go to that square first. Does that square ignore the lines that we just created? Imagine a clean square. Does that square have rotational symmetry? And what is its smallest degree rotation then? 90 degrees, right? Okay, we could turn that square 90 degrees, and this has rotational. And its rotational is 90 degrees, right? Imagine that rectangle. Erase the lines, start fresh. Does that rectangle have rotational symmetry? What would that rotational be? Now that one's got to be 180. It's situated like this. A 90 makes it long ways vertical. That's not happening yet, is it? In order for it to land on itself, I got to make one more turn, which takes it to 180. And as we then say, this rectangle does have rotational, and for it to land on itself, carries onto itself, is what we said. The only way for that to happen is it's 180-degree rotation. Okay. Now the tricky one, or one of the trickiest ones, I don't know why, it always is, and we'll talk more about this on Monday too, is the equilateral triangle. So, does that one have rotational symmetry? Mm-hmm. Don't raise your lines. I'll raise mine. Now I heard a yes. That is definitely correct. It does have rotational. But finding the degree. What's that? Not quite 135. It's not going to probably be necessarily an obvious number. Okay, so here's how we're going to do it. And we're going to do more with this on Monday, and we're going to see some of it here in just a few minutes, I think today as well. But we'll do a lot more with it on Monday. All right, right there in that center, okay, we've got from those vertices, these all meeting, okay? Right around that center, how many degrees is sitting there? Because I just drew that. How many degrees is sitting there? 360, right? Now, when I cut that up into how many angles? How many angles did I just cut this up into? 3 angles, right? Now, you told me this was a what type of triangle? Equilateral, right? What does that imply about these 3 angles I just created? They are 3 equal angles. 360 just got cut up equally into 3 angles, right? So what is 360 right there around the center divided by 3? 360 divided by 3 is 120. So what this has just found us is the degree of rotation. Okay? Around that center point that's right there, that is giving me the degree of rotation. That each individual angle right there is 120 degrees. So if I turn that patty paper, if I turn that triangle 120 degrees, if we were to get our protractors out from yesterday and did exactly what we did yesterday, and we put our compass right here, and I erase that. If I put our compass right here and turn that 120 degrees, dang it, this thing would turn and land on itself. Okay. So what this triangle has, this specific triangle, has rotational symmetry, yes, and it's actually going to be 120 degrees. That's the only way it's going to land onto itself. And it's all going to go back to that center point. Around that center point is 360. And how do I find that angle? It's going to be divisible by however many angles are right there. Okay? You just did that on a square. A square is Captain Obvious, though. On a square, let's think about this. How did you get that 90 really quick? 1, 2, 3, 4, right? 1, 2, 3, 4. 360 divided by 4 is 90, right? All right, we're going to see some more of that here. I don't know if we'll see it today, but we'll see a lot more work on Monday. Square's the captain obvious one. All right, let's keep going here. Let's flip it to the next page. All right, on the next page, same questions I'm going to keep asking. Got you some more practice with the shapes. Well, we just did the rectangle and triangle, okay? How about this? What do we got here in front of us? This is what shape? Count the sides. What do we have? This is an octagon, right? Now, before we go in and talk about the reflectional symmetry, let's do the rotational real quick. So, does this have rotational symmetry? Could you turn this a certain amount of degrees and land on itself? I think we can all hopefully agree that this one does have rotational. Yes, it does. Now, the follow-up question is going to be, what's the degree? Okay, I think hopefully I heard from a few of you. That was a quick yes. Now, where are we getting that quick yes from? So I'm going back to that center. And from each vertex, we're going to talk more about this throughout the school year. From that center to each vertex, we call that a radius. Okay, just think about circles. And around that center, as I did on those other two, we have around that center 360, right? This is what we call a regular octagon. This is all regular polygons, we say. All the sides are equal, all those angles are equal. So 360 divided by octagon is what? 8. 360 divided by 8. Yes, 360 divided by 8 is 45 degrees. So if you were to take, again, our protractor from yesterday and rotate that so it lands on itself, it's going to be a 45-degree turn. That's the smallest turn to get it to land on itself. And the way that we're going to calculate that is this skill right here, every flipping time. 45 degrees. Okay? Now, let's come back around. Let's do the whatchamacallit part. Let's do the reflectional part. Is there some reflectional symmetry happening in there? Yeah, there is. Is there more than one line?
Yep.
There's quite a few lines, isn't there? Okay, it's going to get messy on that. I'm just going to say, yeah, there's reflectional happening in there. Okay. Okay, what shape is up next? What shape appears we have next? Appears we have a trapezoid. Yep. On the trapezoid, do we have any rotational symmetry happening on the trapezoid? I don't think so. In order for that trapezoid to land onto itself, I would have to go a full 360. And that does not happen by our definition. It's got to be less than 360. And really, which again, you're going to find out 180 is going to be our max. The rectangle is the max that we would do, a 180 turn. So this one has no rotation, if I can spell that, no rotational symmetry. Because it's got to be 360. It's not going to happen. It's going to be more than 180. It's not going to be. Okay. Does it have at least what? Reflectional symmetry. For sure does. Draw my lines of reflection, guys. How many lines of reflection do you see in there? I know at least one. Clearly down the line, down the middle, vertically, right? Now again, this is just like the rectangle. Earlier you guys said I had some diagonals happening, right? Are there some diagonals happening on this one? And if you're not sure, what can we always check ourselves with? Patty paper. So if you were to try to draw on that diagonal, maybe right here, and fold it over, yeah, it ain't gonna happen. That corner to that corner, maybe that line of reflection might be happening. Yeah, unfortunately it does not. So again, if you're not 100% sure, check with your patty paper. That's not happening, and really we only got the one line, don't we? Yes, reflectional, and in this case, it only turned out to be just the one line, didn't it? Okay. And we just talked about the other two on the previous side, so we're not going to repeat ourselves there. Okay. Now, where does symmetry happen quite a bit? As I said, out in advertisements. Advertisements, there's just a ton of symmetry that happens with that. Now, in there, where else does it continue to happen? Not there. That's a blank page. fonts, okay? And with the fonts, uppercase, lowercase, all right? Different types of font. How many fonts are out there? I mean, there's a ton of fonts out there, right? So depending on if we're doing, Arial times New Roman, Calibri, there's just a ton of fonts out there. But Arial times New Roman, those are kind of your go-to fonts. Comic Sans, we don't use Comic Sans, that's just weird. All right, but all right, depending on the type of font there is out there as well, changes what you might have in one font where you may not have it in another font, right? Do you italicize that as well? So it just kind of depends off of that. So let's run through it really quick. The biggest thing I can tell you here on these, read carefully. That's the biggest mistake I see. So on this first one here, we're going to take these 4 letters. Let's pretend like we're at the eye doctor. All right, so as we do this, everybody cover the left and right eye. I'm joking. I see if I can get anybody to do that. Okay, which letters have a horizontal but not a vertical line of symmetry? So A, C, H, and M, horizontal but not a vertical line of symmetry. A, C, H, M. What do we got? Have a horizontal but not a vertical. C, and I heard an H, but H I think does have a vertical though, right? H is the one that has both, doesn't it? So that's where I said you got to read carefully. H is the one every year students do suggest that as well. But C has a horizontal but not a vertical, does it? H has both, so don't circle that one. What does M have? M has the vertical but not the horizontal. Those are good test questions. Those are good SAT, ACT style questions where you better make sure you're reading very carefully. Those are just easy things to misread and circle or select one too many things. Are we good on that one? All right. Flip it now. Letter or letters that have a vertical but not a horizontal. Across the board, what do we got? M does. Anything else? I'm sorry? Does B? No. Does H? Does X? I think X has both, right? And H has both, and B has the, but not the, so best we can say is M, right? So again, take your time, run back through it, because I think I heard somebody say maybe X on that last one. Just take your time on it. Run it across now. Finally, where are we at? We are at both. And as we do both, run it across. Both. H, there's finally our H. Now, the one that gets everybody every year is that Z. Does the Z have it? And if you're not sure, what could we do? We could use that patty paper. So if you're sitting there and trying to figure out if Z has it, what can we do is trace that Z on there and see if you fold it vertically or fold it horizontally on that Z, right? And the Z messes up with students on there. So my suggestion is you take that last quiz, and then most importantly, you take that test. Is you run into Z for that, and also it's rotational. Doesn't matter which one it is. If you're not sure, check yourself with the patty paper. Okay. So Z does not have it, does it? Okay. Back to the rotational now. 180 basically and less. All right. Less than 360. Does Z have rotational? Okay. Does Z have rotational? It would have to be, what did it have to be to get Z? Z, I think, has it, doesn't it?
Yeah.
I think it works. So you can take your patty paper, trace on Z, and then if you turn your patty paper, 90 doesn't work, does it? But I think if you turned it 180, I'm pretty sure Z gets you 180, doesn't it? So I think Z works. I think Z works for 180. It's less than 360 as it's defined. So I think Z works. Is W gonna have any rotational? No, the only way W would have to be is a 360, and that doesn't count. Is K working?
No.
No. Is M working?
No.
No, none of those work. The only thing that's happening is Z. Okay. Now those all work, but the lowercase ones work. Depends on the situation, and then the other thing would be if we put those in italicized or if we change them completely to a different font style. You know, some of those may still work or may not, depending on again the font style. All right, on the last page, here, kind of just talk about that, but I'm not going to go through and just run through all that. Okay. Let me see down at the bottom. Okay, yep, this is the last one here. We're going to call it. Yeah, we're going to go ahead and do this one real quick just because it is good talking about the regulars, and we'll finish this off. Let's do the rotational here. We're just going to do the rotational for this regular hexagon, and we'll talk more about this on Monday. Does this one have rotational? Okay, it does. Now let's calculate that rotational. So to determine that rotational, again, what I'm doing here is bringing in these radii, multiples radii. It's always, if you haven't realized in a couple that we've done, we're doing another one, it's always based off the number of sides. So as I draw those radii around that center 360 equally, divided by, because it's a hexagon, divided by 6. 360 divided by 6 is?
60.
So the rotational in this one I heard is a quick yes. And then after that quick yes, what's the minimum degree rotation? Turns out to be 60 degrees. Okay. Now, after that, excuse me, letter B is actually B is an odd one with the isosceles right triangle. To get that isosceles right triangle here, it looks like it's got rotational, but actually does it? No. In order for that to happen, what do we have to do? Bring it all the way back around. The only thing the isosceles right triangle would have for itself would be, as I heard somebody say it, would be reflectional. Okay. Clearly that has reflectional, but it doesn't have. This one has reflectional, but doesn't have rotational. And the last one we'll do is the pentagon right below that. Again, it says it's regular pentagon. So pentagon is 5 equal sides, 5 equal angles. So right there in the middle, 360. I think we could all quickly agree that there's rotational happening. So what is that degree of rotation? 360 divided by 5, and as Carter's suggesting to us, should be, yes, 72. So rotational is happening. Again, I think we probably could agree that there's reflectional also hiding in there. There's several, not several, but there is at least reflectional. There is several reflectionals happening, and the minimum rotation that works is 72 degrees. Okay. All right, that's what we're going to leave it. Let me see the assignment out for you. And then if you have questions over last night, I will bring up last night. Take them from you. Just give me a second. Off of that. Do the assignment for you.
Hard lesson.
Okay. Here's the assignment.